Alright, so this is your video on friction. The important thing is I don't know if this is in your notes. This is the kinetic coefficient of friction. And the S stands for the static coefficient of friction. I can write of friction if that makes you feel better. Of friction. Of friction. So you will need to be able to calculate these, which is pretty easy if you know what both the normal force and the force of friction are. So let's try a practice problem with these. I'm about to clear this. Alright, so the question, though poorly written, it says, if a shoe requires 12 newtons of force to make it move from a stop and weighs 3 newtons, what is the mu static, or mu s? So remember, this is for static, so it's coming from a stop. So we want to find the mu static. So as always, draw a free body diagram. So the shoe has to be pulled 12 newtons to move. It weighs 3 newtons. However, you know that since it's not falling through the ground, there has to be 3 newtons up for our normal force. And since it just moved, it just started moving, it has to have 12 newtons of friction. Alright, from here, now that we figure out, our force of our pull has to be equal to our force of our friction, it now becomes a pretty easy problem to solve because the formula stays the same. It would be force of friction is equal to the mu. This is the static mu because it's not moving yet. And the normal force. We know what gravity is, so we can go back and say normal force is equal and opposite again. So our normal force will be 3 newtons. We're solving for our static mu. And we know our force of friction is 12 newtons. Divide both sides by 3 in this case. And we get your newtons cross out, so we get mu static is equal to 12 divided by 3, which is 4. I'm going to do another one with mu kinetic. So clearing all drawings. So now it's mu kinetics. Formula is the same, except now it says mu kinetic instead of mu static, or S. So let's have our problem. Alright, so the question is, if a shoe is 1 kilogram and pulled at constant speed with a force of 8 newtons, what is the mu kinetic? So as always, draw your free body diagram. There's my shoe. It's beautiful. We know that there is a force of gravity. We don't quite know it, but we're close to knowing it because we know it's 1 kilogram. And we know there's an equal and opposite normal force. And that's being pulled with a force of 8 newtons at constant speed, so that means it must be canceled out by a force of friction that is also 8 newtons in the opposite direction. But we do have to figure out what our normal force is to solve our equation. So we know that force of gravity is equal to the mass times the acceleration of gravity, which we know to be 9.8. So you multiply this, you get 1 times 9.8 is 9.8 meters per second squared. Then we know that the force normal is equal and opposite to that. So now we have all of our pairs for this. So its force of friction we know is 8 newtons, opposite of our pull, is equal to the mu kinetic times the normal force, which is 9.8 newtons. Divide 9.8 newtons on both sides. Plug that into your calculator, and you'll get mu kinetic is equal to, you'll get 0.82 would be your final answer. There are no units on this because the coefficient does not have any units. Hopefully this helped you understand a little more how you would solve for the coefficient of friction in a given problem, such as our shoe lab tomorrow. And I will see you tomorrow.